you know that capacitor is a device for storing charges. When you charge a capacitor, you have to connect a battery. So when you connect a battery to a capacitor, electrons will be transferred from one plate to the other plate. So battery is doing work. That work is stored here as energy. Now, in this video, I am going to explain the derivation for the energy stored in the capacitor. So when a infinitesimally small amount of charge dq is transferred, work done is dw, that is equal to v into dq. V is the potential difference. So potential difference is the amount of work done to bring unit positive charge. Now when you transfer a charge of dq, the work done is v into dq. This is for unit charge. So when you bring a charge of dq, work done is v into dq. Then q is equal to cv. So for this v, you can write q by c. Then the total amount of work done is obtained by integrating this expression. Lower limit is 0, upper limit is q. C is a constant, so you can take it outside. Then integral of q is q square by 2. Apply the limit. Lower limit is 0, upper limit is q. So when we apply the limit, you will get this expression for the work done. But work done is stored there as energy. So for this W, you can write U, where U is the energy stored in the capacitor. Now for this Q, you can write CV. Q is equal to CV, so it's square. Now one C will get cancelled, so energy stored in the capacitor is half CV square. Now to understand where this energy is stored in the capacitor, you substitute for the C. Capacitance of a parallel plate capacitor is given by this expression. C is equal to epsilon 0 A by D. Then potential difference V is equal to E into D. So for this V, you can write ED, then it's square. Now D square and 1D, so it will get 1D will get cancelled, so half epsilon 0 A D, then E square. So this is the expression for energy stored in a capacitor. Now this A into D is the volume. A is the area of the plate and D is the distance between the plates. Area multiplied by the distance, you will get the volume of the space in between the plates. So energy density is obtained by dividing by the volume. So this is the energy stored in the capacitor, you divide by the volume. So you will get the energy density. Energy density is the energy per unit volume of the space in between the plates. So you divide by AD, then AD will get cancelled. So you will get the expression for energy density. UE is equal to half epsilon 0 E square. From this you can see energy density depends on the electric field, not on the size of the capacitor. Energy density is depending on the electric field.